Hi guys. Last autumn we were in London to give a talk at Black Hat about how we use cross-gen to do advanced detection and early detection of web-based threats. So we saw a lot of new emerging web threats that are very difficult to detect. That's why we put in place specific system and techniques for doing it. So what we use here, we basically extract indicator of compromise from a system that collects this information, and then we use this indicator of compromise together with some machine learning to do this detection. So I'm not sure how many of you know what is an indicator of compromise. Just quickly and briefly, these are basically artifacts that are used to identify whether a system has been compromised. So it could be a registry in Windows, a file, and so on and so forth. So let me start with a small question to you. So I'm going to show you a couple of images of web defacement, and I will tell you what makes them, similar to each other. You can see this one. Then we have another one here, defaced by a second group called Teach, and the third one here. So they look pretty similar to each other. So what they have in common here, the three of these? All right, so it's the rendering layout. So they all have this matrix style background with letter getting from the top to the background. They have like fancy colors, black background, and maybe like functionality like to trace like the user that visits this page in order to perform possibly, for example, drive-by downloads infection. So all this content that is embedded by the attacker on this deface page is often benign, like libraries, as well as beautifier to control the look and feel in the page, or a bunch of other functions. So this makes very difficult to detect these pages because the page itself is not malicious. But it has this, what we call this indicator of compromise, that are actually benign library in most of the case, but they are used, the context in which they are used is malicious per se. So the idea here is that we use this contextual information to detect like pages that have been compromised and consequently the threat that they embed. So how we do it, we collect this information on a regular basis by having a distributed web honeypot made of more than 500 vulnerable web applications of different types. And then we use cross-gen together with a technique which is called unsupervised learning to basically identify these pages and cluster them in groups. And these groups are a group of maliciousness, so we can have, for example, web shell, as well as other examples we'll see later in the talk. So that's very interesting because these techniques show us that we can do early detection. So this is a plot showing that we, on the x-axis, you have the days. So we can see that we have a lot of pages being detected 1 year, 6 months, 1 year, and even 2 years before our competitors, including 0 days and including pages that were actually benign and using malicious context, but benign. So some examples of the things we detect that are very difficult to detect are phishing, especially when the attacker phish using a URL from the original website. For example, if you want to phish PayPal, you can embed like directly like, the JavaScript from the PayPal website. So the page is actually benign because it's using a benign JavaScript file again, but at the end is using malicious context. So we have phishing, we have web shells, that is very common like technique used by attackers to keep like persistency on the infected machine, as well as web shell that are locked with login accounts. And then we saw a lot of hardware campaigns as well as charity program. So we were able to trace wherever the website is affiliated to another one. And for example, in the case here, you have a shopping site that is actually affiliated with a lot of other websites that actually turn out to infect your machine. So to conclude, we use machine learning, or if you want to say, we use cross-gen to validate this indicator of compromise and do early detection, especially in these cases that are very difficult to be detected with a normal system like scanner of static code. Because, as I said, most of the case, this content is not malicious per se, but is used in malicious context. So we do early detection, and our system is currently, we believe, very, very efficient. So I would like to thank you and to remember that all this material will be made available on our web page, including the presentation and the paper. Thank you.